So I pushed the wrong button, and that was that. And so we'll continuing. And the next problem, which I find quite interesting, and problem 29, and which is about the number of people who has codes. Okay, now let's so we have the information here. The number of people for problem 29, the number of people who have codes is let's see. So in 2005, okay, 2005, we have a certain number of people have codes 12025. Never mind how they know that, but and then the decrease rate that is 205 per year. So m, that means m equals to negative 205. Okay, divided 1 year. So the rate the rate difference y2 minus 1 is 2 over 5 per x2 minus x1 is 1 year. So that is the m is equal to that value, and therefore, all right, that's all the information we have. The question is, when will 0 people catch codes? Now that's pretty awesome thing to think about, right? So we have so we will use this formula again, right? We have then, right, let's write this stuff down. So we following the formula, we have y minus y1, which is that thing, 12025, equals to m, which is minus 205. Yeah, the slope, which is per year, is always the rate of change is m, which is the slope. Okay, and then times x minus x1, x minus 2005. Okay, and we want, what do we want? We want y to be 0. When will the output reach 0? What's the output? And that is the number of people. Yeah, so we need this number equal to 0 to see how that works, to calculate x. Okay, so set y equal to 0 in this equation, and we'll solve this thing. We will have minus 12025, okay, divided by this number here, which is minus 205. That will give us the x value right here. Okay, so x minus 2005. And that means x equal to this value added by 2005. So let's figure out what x is. So x equal to, what is that anyway? So let me use the calculator to calculate this thing. Okay, I found my calculator. I need to turn it on again. Okay, 12025 divided by 205. Okay, that will be equal to, and then plus 2005. Okay. Okay, now so here's let's see, I think I hold it, if I hold my calculator about here, you can see it better or something. Yeah, so here's what my calculator says. Now that equals to what I did is we calculate this thing right here, and then I moved the 2005 added to this result by moving the number over. So the final result then is 2063. So if the trend holds, then by 2063 or so, or 4, if you round things up, and then nobody will have any codes if the trend holds, which is probably not gonna, because linear models are not that good of a predicting this type of thing, but it's still interesting to think about. Now let me check the answer to see if I got it right. What problem is this again? 29? Yep, 2063. Although I got the number point some 5 or 6 or something. Yeah, I should round up to 2064. But I guess your book doesn't care, so we are not going to be too picky about it. Next problem, let me erase the board. So the next question we're going to talk about is problem 33, but I just remember the joke that I want to tell you. There was once this interviewer who was interviewing kids because she was looking for geniuses, or something. So she will interview these kids. They are about 10 or so, and ask them, what do you think will happen in the year 2050? And back then that was about 2010. And so all the kids tell her about flying cars and robots and whatever cool things the kids can think of, right? And so she listened to all that stuff, and then this one kid came in and she asked him the same question. And the kids thought about it, and what will happen in 2050? And the kid thought about that and says, well, for one thing, February is going to have about 38 days. And the interviewer says, what? Why do you say that? And the kid says, well, my brother told me that February has 28 days, but every 4 years, it gains 1 day. So then, obviously in 2050, and which I thought was very cute. And anyway, it's a very similar kind of problem. So anyway, so let's now look at problem 33. We're looking at this graph, okay, and we are trying to figure something out about it. What about this graph? Well, at 15, here are the two numbers. When x is 15, what am I writing x? I mean 15, let's write 15, okay? When x is 15, and the y value is 150. And then when x is 25, the y value is 130. All right, so the question is, what would happen if what will be x when the y value is 0? So as you can see, it keeps going down. So eventually it might hit 0, right? The y value might hit 0. What would x be? So let's do that. And to calculate that, first we need to find the slope of this thing. That is, what is m? So to calculate m, we will have this one subtracted by that one. Okay, so 130 divided by 150. And all right, what? No, I mean subtracted. 130 minus 150. Okay, because the m is given by y2 minus y1, and it doesn't matter which one you pick as y2 as long as you're consistent. If this guy is y2, then this guy is x2. All right, so we have picked this guy as y2, so y2 minus y1, so this guy will be x2, so x2 minus x1, so that would be equal to m. That's 20 over 5. Negative, don't forget this is negative because the slope is going down. Okay, and when I say going down, I'm talking about when we are walking from left to right, that is going down. So this is a slope that's negative, goes like this, is a decreasing slope, and the slope that the other way is an increase. Positive slopes are increasing, and what you're doing is you imagine you're walking this way. Okay, so this is the decreasing going down slope, and that's the increasing slope. Okay, and anyway, so 20 over 4, that's minus 5. So the slope equal to minus 5, and knowing that, we can write our equation. Y minus y1, which is 150, following this equation right here, okay, equals to m, which is minus 5, times x minus x1, which is 15. All right, so now we need to know what value is x when y equal to 0. So we'll write this down, y equal to 0, so we have 150 here left, and divided by minus 5, we'll push the minus 5 across the equal sign down below the division line. And so that this side has only x minus 15 left. And that will give us, so this side equals to 5, that's 30, okay? And so then x equal to 45, right? Because I pushed the 15 to the other side, that's 30 plus 15, that gives us 45. What happens at 45 again? That's called the x-intercept. That is when the graph goes all the way down and until it cuts the x-axis. Now, when x is 45, that is, the graph is the downhill one, right? So eventually when x is 45, y will be 0, okay? So y value is 0, and that means what is 45 anyway? But anyway, at 45, at the year 45, or 45 years after something, 1980 or whatever, that the company will make 0 money. is what that means. You see, it hit the ground. So yeah, let's hope they do better than that. And that's problem 33. Yeah, I checked the answer and I did not get it right. So where did I go wrong? Let's look at this stuff. 25 minus 15. Why do I have 4 here? I have no idea. Okay, that should be 10, shouldn't it? That would be much better. Okay, that is, although minus 5 isn't a bad answer, but it's still wrong though. That should be minus 2. If it's minus 2, then, okay, so we'll change the 5 to 2. Okay, change the 5 to 2, please. Only 2. Okay, so that would be 70, right? So that is 70. Is that even right? Let me check some more. Okay, now let's. This should be 75. Okay. So then x, instead of being 45, should be a lot more than that. 75, that's 90 years later, right? So x equal to 90 is the right answer because the book says the company will go get 0 profit in the year 2070. All right, which is, it started at 80, so 9 plus 8 is 17, so that should be okay. Yeah, with that, that should be the end of this section.